Hello teacher, this is team 27 from machine learning class. Our team has 3 members: Nguyễn Nam Khánh, Vũ Việt Khánh, and Phùng Trí Kiên. During this video, I'll talk about 5 parts: representing the data, our approach to the problem, the model we used, the experiments we had, and the result. First, in this collab file, we only handle the posters. The reason we will explain it later in the video. So in the poster, we save the URL for each poster and only get the poster when being called. In case we do not find the URL, we randomize a NumPy array. We change the table format to NumPy array and resize all the image, and we also create for augmented training dataset to enrich the original dataset. Then we apply normalization and split the dataset to patches of size 32. So in this code, this is the way we represent the image if the path exists, and if not, we resize the image and then we change the data format and normalize. This is where we transform then enrich the dataset here. This is where we split into patches of size 32. The titles, we do not cover it in this code, but we tried it. We tried to remove characters, convert all to lowercase, tokenize them, and since the final token of each title is the release year, so we delete it. We don't consider that useful for training. And then we create the vocab. We fix the size of each token and create a type vector in which each number is the position of corresponding in the vocab. We create a one-hot vector of 18 labels with values of 0 and 1 to represent whether or not the film belongs to the corresponding gender. To approach the problem, we trained 2 independent models, one based on ResNet 50 for poster processing, and one is using RNN architecture for title processing. And then we will eventually combine the results and hope the result will compensate for each individual model's errors. Using the ResNet 50, we apply the transfer learning and we freeze all layers except for the last layer, which we also change the last layer based on the output of the problem. The freeze layers use pre-trained ImageNet 1K v1 as parameters. Here's the picture that depicts the process. There's the backbone, and this is the linear layer. With the RNN network, we use an embedding layer to convert all the title vectors into embeddings based on the vocab with 3,899 tokens that we built before. And then we turn each type vector into embedding. After we turn each title into embedding, we run it through an LSTM layer, and then we apply the linear layer to make the output into a form we want. This is the image that describes the process I just said. We conduct a total of 3 experiments. First one, we run only the RNN network. The second, we run only a ResNet network, and third one, we combine the above 2 results. Running the RNN network, we test many different hyperparameters and finally arrive at the most optimal model possible. By training with 60 ASBox, in which 20 of learning rate 1e minus 3, 30 with learning rate of 1e minus 4, and 20 with learning rate of 1e minus 6. We use the Adam optimization function with weight decay of 1e minus 5, and we just the cross entropy loss. By doing this, we hope that it will help us overcome the problem of unbalanced dataset. Now here we train the design FreshNet50 backbone for 20 epochs with learning rate 1e minus 4, and then decrease the learning rate to 1e minus 11 and keep training for 10 epochs. We also use the Adam optimization function with also the weight decay of 1e minus 5, and we use the binary cross entropy loss function. During experiment 3, we take the outputs of a FreshNet50 backbone and create a prediction with the threshold 0.25, and we use the threshold 0.3 for the output of RNN network, and after that we combine the two predictions. Here's the result that we had, and as you can see, FreshNet50 backbone network has the highest F1 score. The low precision and high recall are because we could not handle the imbalance data problem well. And so that is why we only choose the code that handle the FreshNet50 code that we train the posters to submit as a final result. During the code that we submit, we will submit to file the doc file which will have our YouTube link right here, and our .ipynb file. You can upload it in Colab and run all. Just click on all, and the code will reproduce the result, or at least something similar. This is where the model run. As you can see, this is the FreshNet50 backbone, and this is the linear layer. This is the Adam implementation with weight decay 1e minus 5. This is where we train with the first 20 epoch and the final 10 epochs, and this is the result we have, and this is the evaluation. Yeah, that's out. Thank you for listening.